A biome is a climatically and geographically contiguous area with similar climatic conditions, and it's associated with um, communities of plants, animals, soil organisms, and viruses um, that have the same kind of biotic and abiotic factors over a large geographic area. So biomes are defined by factors such as plant structure, in other words, trees versus shrubs versus grasses, or leaf types, such as broadleaf versus needleleaf, or the plant spacing, like forest versus woodland versus savanna. And the major thing that they're defined by is the climate. So in this photo album, I've included photographs from a number of my journeys on 5 different continents. And you can see here, this is a savanna. This happens to be in Uganda. This is a temperate deciduous forest in Netherlands. This is out in Death Valley, California, which is a very dry, hot desert. Here we have, this is Rocky Mountain National Park. So we have a coniferous montane forest. And as you scroll through these, you're going to see a variety of different biomes with vegetational differences, which are a result of very different climatic regimes. So you can see, again, the spacing of plants makes it different. Here we have a savanna. This is actually outside Austin, Texas, of very much a savanna-like type environment, which is going to be different from the forest type environments. Here's a forest of aspen trees in the Sierra Nevada, or a forest of trees here on Oahu, Hawaii. And you can see even by the pictures that climate's going to vary dramatically between them. This is actually taken in Whistler, British Columbia, which is a popular ski area and so forth. This is taken up at Precipice Lake in the Sierra Nevada mountains. And here we have what's an alpine tundra. And right now the vegetation is not visible because it's still covered by the remnants from winter snows. Now, if you scroll through these photos, you hopefully can see, again, a wide range of vegetation, and you can probably have some kind of a sense that these things have very different climactic conditions. Here's a couple from Los Angeles. This happens to be the mountains on top of Mission Peak, just overlooking the San Fernando Valley, and similarly here in the hills above Sylmar, and the San Fernando Valley and so forth is down there below. So what we want to look at is we want to look at the climactic factors which are associated with these radically different types of biological communities. So to do that, we need to define, again, what a biome is. And as mentioned earlier, it's a contiguous area with similar climactic conditions that has similar biotic factors. So, for example, in Southern California, we live in this Mediterranean woodland. We refer to it as a chaparral right here. And the Mediterranean forests, woodlands, and scrubs are found in various different areas of the world, particularly in the Mediterranean region. There's southern Europe and little bits of northern Africa, southwestern Australia, southwestern Africa, and a little tiny section here in southwestern South America on the area of Chile. Now we want to look at the differences in vegetation and corresponding differences in climate for 3 different places initially here. Iquitos, Peru, which is in the Amazonian basin here. It's It's in very close to the equator. It's a lush jungle biome. Tindouf, Algeria, which is perhaps the hottest and driest place on Earth, or certainly the hottest place. And then Point Barrow, Alaska, which is up here on the very northern tip of Alaska. So when we scroll through here, we can see that here we can see the climographs for those 3 different cities. So here's the climograph for Iquitos, Peru, for Barrow, Alaska, and for Tindouf, Algeria. By comparison, you can see Los Angeles right here. So in looking at these, we want to have the same axes for all of them to make valid comparisons. And so we've put precipitation on the left vertical axis, we've put temperature on the right vertical axis, and we've defined a max and a min for each of these axes so we can compare them. If you're going to graph them, that oftentimes what will happen is that they will be scaled so that you get the maximum values. In other words, so you can see even slight variations. So for example, on this one here with Barrow, Alaska, you can hardly see any precipitation. That's because we've graphed it from a minimum of 0 millimeters precipitation to a max of 350, just so we can compare it here with Iquitos, Peru, with the same axis. If we just plotted automatically, it would probably put this as full scale, so it would appear very tall. But again, our purpose is to be able to compare the climates between different cities, so we want to make sure that they are indeed on the same axes. And so you can see here again that Iquitos, Peru is equatorial. There's very little difference in terms of the temperature from one month to another. Whereas Point Barrow, Alaska has dramatically different temperatures between the winter months and the summer months. And the winter months are extremely cold. We're talking temperatures approaching minus 30 degrees Celsius. And the temperatures in the summer only reach about 4 or 5 degrees Celsius above zero. Now, contrasting that with Tindouf, Algeria, which is this very hot, dry desert, we can see, like Barrow, Alaska, it has very little precipitation. And it also has very big seasonal variation in terms of the temperature, unlike Iquitos. However, the seasonal variations in temperature are, although they have a similar shape to Barrow, Alaska, they're at a much higher level. So we can look over here and say that Algeria does cool off in the winter months, but in the summer months it's cooking there. It's like 35 degrees Celsius. So a full 30 degrees Celsius higher than the highest temperature you're going to get at Barrow, Alaska. So we want to use data here in the Google Sheet spreadsheet that I provided with you to be able to create climographs for all these different cities. Now, the purpose of this is to understand both the science behind the distribution of biomes, but also to master some of the graphing skills that you're going to find in spreadsheet programs like Google Sheets or Excel. And so what we're going to do first of all is we're going to graph the data, and we're trying to create a graph similar to the one that you're seeing right here. So this is the graph for Iquitos, Peru. It's a climograph, and again we have rainfall on one axis, we have temperature on the other axis. And so we're going to try to match that right up front here by highlighting from B4 here where it says month all the way down to N6, which happens to be the December temperature for Iquitos, Peru. Then we're going to select the graphing tool to say insert a chart. And if we look at this, we notice this does indeed show rainfall, and it doesn't indeed show temperature, but the graph looks nothing like what it does over here. So the default for Google Sheets is to look for data in columns, but our data has been provided in rows. So we have rainfall in a row, temperature in a row, rather than in columns. So we're going to switch rows and columns, and now our data looks a little bit more reasonable, but we're still dealing with a horizontal chart rather than a vertical chart. So we can select up here the charts, but before we do that, we can look at the ranges and so forth right here, and we can see that we have selected in this one right here chart 20.25, which happens to be 20.25, Climographs, okay, which is again this particular sheet, and we're selecting from B4 to N6. That's exactly what we want to look at. So we're just going to close that out and now go to our charts over here. And in this case, we're going to use a line chart, but it's not just a pure line chart. We're going to put on a histogram as well. So we're going to use the combo chart feature, which is right here. And immediately we can start to see it's looking more like what we see down below there in the lower left. Okay, so here we can now go to the customization. So if we go to Start, then Charts, then Customization, just go from left to right. And you always want to label your graphs. This is going to be for Iquitos, Peru, the climograph for Iquitos, Peru. And we want our legend to be on top, so we're just going to go right down here and say we'd like our legend on top. And now that part's looking the same. And as we scroll further down here, we can see, okay, that there's a horizontal axis and it has no title. So let's go ahead and put in there month. And this month here will give us the month that we see at the bottom. And so now as we go on, we can see that that indeed came in. And now we have to define our series. Now, series means two sets of data, or two or more sets of data that are plotted on the same graph. In this case, we have rainfall and we have temperature. Now, the reason that rainfall and temperature appearing here are automatically put in is because we highlighted them over here. We started from those category headers, and if you go back to the start section right here, we instructed it to use column B as headers, which indeed is what it's doing. So if we are coming back over here and now looking at our rainfall, we want our rainfall to appear in the left axis. So this is the left axis, that's rainfall, and we want the color to be blue because people kind of associate blue with water. We could have chosen some other color like green, but again, blue makes the most sense in this particular situation. When we click over to temperature, temperature's coming up red. That's again just the default is blue and red, but we could change that as well. We could put points on this graph if we want to actually see the values for those, which we'll do in this particular case. And right now it's selected as a line graph, but we could choose it an area graph. We could choose it a column. But whenever you look at this, you'll notice that whatever one we choose does not match the red that we see over there. So let's go back here to a line, and we notice now that this is going to be plotted on its own axis. It'll be different. So we're going to, instead of plotting it on the left vertical axis, we're going to plot it on its own axis. And now it looks quite different. What before there was minimal differences, now you can see significant differences between those temperatures, or at least significant for this graph. However, you'll notice that the red line here does not resemble the red line right here, other than that there's a small dip here, and that corresponds to this dip right here. Well, an examination of the axes notices that this is plotted here from -30 to +30, whereas here it's plotted from 25 to 27. So what we need to do here now is we need to modify the minimum and the maximum values here. So I'm going to say insert this, which is going to insert this into this sheet, and I can move this around. If I click on it and I get that little hand, I can drag it over here, or someplace I'll just leave it right here so we can now compare this versus this one. And I'm going to enlarge a little bit, just like I would any graphic, just to make it a little bit easier to see what's going on. If I click on the axis over here, that gives me the ability to change the values. I'm going to say that our minimum will indeed be 0 for precipitation, but our maximum will be 350. So we've now selected that as 350, and we're going to click over here and we'll do the minimum here. Let's say that our minimum temperature is going to be a -30 Celsius, and our maximum temperature is going to be +30. And now we can see that the graph is starting to look much more like the graph over here. Well, the next operation to go here is to be able to label these axes. And so we're going to click on this triangle here and go back to the advanced edit. And under the advanced edit, we can see one of the features here is to be able to label those axes. So if we go down here to the axes, before we just saw the horizontal, now we have a left vertical that we need to define, and we're going to define that as precipitation in millimeters, always include the units. And then we'll change it to the right vertical, and the right vertical in this one is going to be temperature, and we want that to be in Celsius. Now you notice we could do the same thing over here. We can put our minimum or max, we're going to put it in right there, and we'll simply say update the graph. And now we have a graph which looks very similar to the graph that we had there before. Now we can take that graph and we can put it on its on a sheet here, and the advantage of that is that if you put the sheet here, okay, then if you were to make a change in the table, you're going to be able to see the change immediately. So for example, let's say we changed the temperature here for 1 month in Iquitos, Peru. So let's say in terms of the June temperature, let's say instead of 25 degrees, we put in there minus 25.5 degrees. So let's say we had the sign change. And you'll notice that the graphs change dramatically, and we can see those changes instantly as we do that. Let's go back and change that to 25.5, and we can see now that the graph resembles our original. So the value on this is that you can see dynamic plots of the data as that data is occurring. And so when you plot it in its right next to the data, then students can see as the data changes, the graph will change correspondingly. Now alternatively, you could put this in its own sheet. So if I click on this and say I'd like to take this and move to its own sheet, it's now going to appear here as its own sheet, and one of the advantages of that is that simply you can see it in larger detail, and that's going to be advantageous when you're trying to project to an entire class. At any particular point you can copy the chart, and you can copy the chart and paste that into a Word document or some other type of web page or resource. This is still dynamic. The only problem is you can't see the data and how it changes. So again, if I go back over there, and let's say I was to change the temperature, or let's say the rainfall here for Iquitos, Peru to be 20.76, again with the decimal off there, we can see it adjusted right there, but we couldn't see it on chart 2. If we clicked over here, we now see it there, but we don't see it automatically. Now it's best to not just call these charts, by the default names, but if you click on it, you can rename them, and we're just going to rename this one to be Iquitos. You can also maybe hide these if you need to. When you hide the sheet is still there, and if you click up on View, you can say that hidden sheets, and you can get it to appear. And the reason that this is advantageous is if you get a lot of tabs down here at the bottom, then you can hide those tabs and just expose the ones you want to, but they're still all at your fingertips to be able to describe the various things that you want to see. Now, let's say we wanted to plot what we've seen here for Iquitos, Peru, plot that same climactic data for Point Barrow, Alaska. Here it's a little bit trickier because our category headers here are not adjacent to our values here. However, if we highlight the first column by clicking on B4 and scrolling across to N4, and then holding down the Command key on the Mac, I believe it's the Control key on the PC, we can now highlight those zones, and we can go ahead and click on Insert Chart, and now we're posed with something which we've not seen before. This data looks totally weird, and that's because we're combining the ranges horizontally. It thinks we're looking for horizontal ranges here. So we're going to try vertically, see if that looks any better, and no, it doesn't, but that's because we need to switch rows and columns as before. And now we start to see that we're getting, again, more reasonable types of data. We can see that it definitely is changing on a monthly basis. And we're going to use column B as headers. Again, that's going to be month, rainfall, and temperature. And now we can see, okay, we've got our graphs and so forth there. So before you proceed, you always want to go to the Start menu first, make sure that your data makes sense. And if we click on the data selected ranges on this one, we're going to see now it's choosing two fields. It's choosing B4 to N4, which is basically the months, and then it's choosing B7 to N8, which is 2 rows of data. Now the default is to look again for data in columns. We changed that to looking for data in rows, and so we should be okay with that. So we can just say that's okay. And again, proceeding from left to right, we're going to try to match the right types of charts. So click under Charts, and again we're looking at combination charts because we're trying to plot both temperature and rainfall on the same chart. So let's click on this, and now we're going to see the histograms. But you see the problem over here. It's looking from -40 to 40. It's trying to plot the data automatically, and we've got to be able to adjust those axes and to introduce a right axis so that temperature and rainfall are not plotted on the same. So the next thing we need to do is we need to go to customization, and let's not omit any of the key features here. Let's first talk about what this is. This is for Point Barrow, Alaska. Again, if you want to write the full title, it would be the Climograph for Point Barrow, Alaska, although that's somewhat obvious in this particular case. And we're going to scroll through. We don't need to change the colors of the legends and so forth, but we're going to put the legend up at the top so it matches what we had before. So again, just to see that we want it to match Iquitos, Peru here. And scroll farther down and start to look for some of the various features. Here's horizontal axes. Notice that we have a left vertical axis but no right vertical, and that's because we haven't defined our right vertical with our series of data yet. So let's just choose horizontal and go ahead and title that while we're at it. So now we have months and so forth on that axis. And let's go down to our series. So rainfall should be the blue histogram, and sure enough, rainfall in millimeters is. Again, that title, rainfall in millimeters, is coming right from here because we selected the category header, which again is now in a row, but we were able to do it by selecting that way. And let's now scroll down here and say that for our we want this on the left axis, and let's change now the temperature. We'll keep it at red. Again, if you want to put point sizes to actually indicate the data points, you can do so by selecting here. Those would be the actual values that are connecting the dots. It's not necessary for this particular thing. So, but we don't want it to be on the left axis, we want it to be on the right axis. So now it's on the right axis, and we can start to see, oh, it's starting to resemble the type of graph we have over here. That looks great. The reason why it doesn't look exactly the same, though, I mean, it doesn't look the same as the ones we showed previously, is our axes have different minimums and maximums and so forth. You notice it scaled this so it can show the variation there very easily. But notice at the top here is like 24 millimeters of rainfall. Over here we're dealing with 300. So what we're going to do is we're going to now go ahead and insert it, and we can drag it wherever we want to. Oops, I dragged the data, so let's drag the actual graph there. Make sure you get the little hand. I'll enlarge it again so we can make it easier to see what's going on. And I want to change the left axis title first of all. So let's call it rainfall, millimeters. And we're good there. Now, what we need to do is we need to adjust the axis labels and so forth, and kind of go, oh, I don't see any one to click here. And that's because we never defined it originally. it starts with a default of just a left vertical axis, and so the right one requires a little bit more attention. And it's not a problem because we just go back to Advanced Edit, click on the little triangle, go to Advanced Edit. If we scroll down here under Axes, let's select first the left one, and we want its minimum to be 0 and its maximum to be 350. When we update that, now we can see that, wow, there really is very little rainfall or precipitation in Point Barrow, Alaska. And let's go back over there, go to our Advanced Edit, and let's go down now to look at the axes here, and we're going to look at the right vertical axis. Notice it has no title at this point, so we have to put in their temperature, and we're going to put there in Celsius. And here we're going to define our temperature with a minus 30 to a maximum 30 degrees. When we click Update, we now have scaled it so that it now is going to be a viable comparison with the Iquitos, Peru. So I'm going to click on this, and I'm going to take this here, and let me just drag that up, and I can shrink, pulling from the corner, and I'll try to get the size to match the one you see over here for Iquitos, Peru. And now we can see that, wow, these diagrams, when viewed side by side, really show the dramatically different climates between Iquitos, Peru, and Point Barrow, Alaska, which give rise to significantly different types of biomes and so forth that we see in both of those areas. So for this particular activity, we want to create climographs for all of the cities listed on here, and then we can compare them right next to each other, as we can see right here. And so by putting them adjacent to each other on the same spreadsheet, we can readily compare the various different climactic regimes, and then try to match them to the vegetation zones, in other words, the biomes that we see. So in this particular activity, if we scroll to the bottom of it right here, we're going to see again the charts of the 12 different climographs, and you'll also see a collaborative presentation. And the collaborative presentation, we can just open that up right here. And what we're going to try to do is we're going to try to correlate the climographs with the biomes. So as always, you can make a duplicate of this by simply saying make a copy. And now when you make a copy of it, this is now your own version of this. It looks identical, but the fact is copy of means that it's actually going to be your particular graph and your particular account. Nobody can touch this until you give the privileges. So if you wanted to share this with the world, you can go ahead and click on Share, and I think it's easiest to click under the Advanced one and then figure out how you want to share this. So in this case right here, I want other people to be able to see it, so I could click on Change and then say anyone with a link can view. And that's a pretty good way to go, because if there's a link from your web page, then anybody can view this. Now you may also want to invite people, like let's say your students, to be able to edit it. In this case, we're going to do that here. So I'm going to invite my particular group, which I've already defined my mail group for, and I'll say that anybody in that group can edit. All right. So when you go through the CAPTCHA here, then anyone on that list now is now going to be an editor to that, and nobody besides the people on the list. So all those people can now edit this copy of climographs and biomes. And the idea is that each one of these, I've put a climograph in the upper right hand corner, and again, these could be the same as the ones that you've generated. And then you're going to put onto it a picture. So for example, the tropical rainforest. This is actually taken in Brazil, but would be pretty similar to what we would see there in Iquitos, Peru. So this is why I put that picture right there. This picture here might correspond to what we're seeing here in Iquitos, Peru. Then I'd need to put a picture for the Arctic tundra right there. So on the assignment, you'll see this link here for this database of pictures. So here's a database of pictures. Now I don't have pictures from Point Barrow, Alaska, but I would try to find something which resembled it the most closely, and which is probably going to be right here. And I will right-click on this, copy the image address for here, and now I can go back and I can put it into the Google Slides that we just saw here under Arctic tundra. So to insert that picture, you can insert, in this case, an image, and you're going to do it from a URL from an existing database of pictures. We'll paste that in, and now we have the Arctic tundra picture to match the picture we saw there. Now you'll notice that the Climograph right here is hidden by that, and we can go up to the Arrange tool right here, and we can say the order, and we'll bring this one to the front, which now allows you to size your pictures underneath your graphs without obliterating the data. So what we'd like to do is you'd like to go through this entire sheet here, create one for hot deserts, for Mediterranean woodlands, to temperate forests, and so forth, and be able to create this collaborative presentation here on biomes of the world. So that kind of is the goal on this particular activity, is to both master the creation of climographs, but more generally of combination graphs with being able to have two vertical axes, and then simultaneously using that data to create a slideshow, being able to show you how various different climactic zones here are determined by the climographs that we first introduced right here. Have fun!